Hi friends, today we're going to talk about solving absolute value equations again. But in this case, we're going to have x's on both sides of the equation. If there are x's on both sides of the equation, you need to look for what we call extraneous solutions, which is a solution that is found algebraically. So when you solve the problem, you find the solution, but it doesn't actually work in the original equation. Make sure you know that it's the original equation. So we solve this just like we did our other ones, the easier ones, but when we're done, we have to plug the answers back into the original equation and see if they work. So we might end up with two solutions or one solution or no solutions. So let's look here. We don't have anything on this side of the equation that isn't in the absolute value symbol. So we can right away start and separate it into two separate equations. So the first one is exactly how it looks, but taking away the absolute value. 3x plus 2 equals 4x plus 5. But the second one, we have to set it to the negative value of the right side of the equation. 3x plus 2 equals negative 4x plus 5. So just like how we were solving equations before, we'd set it equal to the positive and negative of the right side. So let's go ahead and solve these. I'm going to take 3x from both sides. So then I have 2 equals x plus 5, or 1x plus 5. Taking away 5 from both sides, we get negative 3 equals x. And now I'm going to plug that back into my original equation to see if it works. So the absolute value of 3 times negative 3 plus 2 equals the absolute value of 4 times negative 3 plus 5. I'm going to put a question mark because I don't know if that's true or not yet. Simplifying the left side, 3 times negative 3 is negative 9. Plus 2 is negative 7. Simplifying the right side, 4 times negative 3 is negative 12, plus 5 is negative 7. We still have to keep going though, because the absolute value of negative 7 is positive 7. So the left side when simplified is positive 7, the right side when simplified is negative 7. Those are not equal to each other, which means x equals negative 3 is not a solution, or it's an extraneous solution. Move this over here. So this is an extraneous solution. It means that we got that answer when we solved the problem, but it didn't actually work in the problem. Let's solve the other side here. 3x plus 2. Simplifying the right side, we have to distribute that negative through, so it becomes negative 4x take away 5, or negative 4x plus negative 5. So continuing to solve here, I'm going to add 4x to both sides. Remember, we kind of want to get rid of the answer, or get rid of the x that's smaller. So now I have 7x plus 2 equals negative 5. Take away 2. 7x is negative 7. And then dividing by 7, we get x is negative 1. But now we have to check and see if that actually works. So I'm going to plug negative 1 back into my original equation. Make sure you're not plugging it in to this equation. Okay, we want to plug it back into the original equation. So the absolute value of 3 times negative 1 plus 2 is that equal to 4 times negative 1 plus 5. 3 times negative 1 is negative 3, plus 2 is a negative 1, so that becomes absolute value of negative 1. 4 times negative 1 is negative 4, plus 5 is 1. And then continuing to simplify, The absolute value of -1 is 1. So that works. So our final answer then is just x equals -1. We don't say the -3 because that was an extraneous solution. Let's look at another one. Again, we have the absolute value portion already by itself, so we can split it up. 7x plus 5 equals 11, take away x. And we have 7x plus 5 equals -11, take away x. Continuing to solve here, I'm going to add x to both sides. So when I get 8x plus 5 equals 11. Take away 5, take away 5. 8x is 6. And then dividing by 8. 6 divided by 8 is 0.75. We can turn it into a decimal as long as we don't have to round, and in this case, we don't have to round. So now let's check this in our original equation to see if it works. Absolute value of 7 times 0.75 plus 5. Let's see if that's equal to 11 take away 0.75. The left side, if we put all of that in our calculator, we would get the absolute value of 10.25. The right side is also 10.25. The absolute value of 10.25 is 10.25. So that one checks out. We know for sure that 0.75 is going to be one of our answers. Now let's solve the other one to see if we'll have two solutions. The left side stays the same. The right side, we need to distribute that negative through, so it becomes -11 plus x. Continuing to solve this, we'll take x from both sides. We get 6x plus 5 equals -11. Take away 5 from both sides. 6x is -16. Divide both sides by 6. This one, we cannot turn it into a decimal because if I simplified this, I would get x equals -2.6 repeating. So you can leave it as -16 over 6 or call it -8 over 3. So we'll check this in our original equation. Again, the original equation. So the absolute value of 7 times -8/3 plus 5 equals 11 minus -8/3. Again, the original equation. Oops. 7 times -8/3 plus 5 gives us -13 2/3, which is the same as -37/3, absolute value of that. The right side, 11 minus -8/3 gives us 13 2/3 or 37/3. And then continuing to simplify, the absolute value of -37/3 is 37/3. So both sides are the same. So our final answer then is 0.75 and -8/3 because both of them worked. So again, if you need the steps, they're up here. Write two equations that represent the original absolute value equation. So if we have something like the absolute value of x equals a, then we would say x equals a and x equals negative a. So the negative version of the right side of the equation. Solve both and then plug the answers back into the original equation to see if it works.